Welcome back. We are now going to solve systems of linear equations that have special solutions to them. And we'll see what that means in just a minute here. So we can see that the first equation, y is already by itself. And so for me, I look at that and I say, oh, that looks like it would be easiest to solve this system using substitution because I already have that y by itself. So in order to do that, using a substitution method, I'm going to take that 3/2 x minus 1 and put it in place of y down here because we're being told y equals 3/2 x minus 1. All right, so let's do that and see what we have here. So I'm going to take the other equation, negative 6x plus 4, and then what the other equation is going to go in there, equals negative 4. All right, so let's substitute that 3/2 x minus 1 in place of where we had y. All right, so now let's simplify this up, see what we have here. So negative 6x, and then let's distribute the 4 to both things inside the parentheses. And remember, when we're multiplying fractions, multiply the numerators together, multiply the denominators together. And so when I do that, I get 12 over 2x, and then distribute the 4 through also. 4 times negative 1 is negative 4, and then equals negative 4. All right, let's keep simplifying. So I have negative 6x, and if I reduce this, 12 divided by 2 is 6, so I have plus 6x minus 4 equals negative 4. Now something kind of different happens here, right? I look at my x's and I say, wait a minute, my x's are eliminating completely out, and I don't have a y to solve for. There's no variable left in my equation to solve for. So I look at this and I say, okay, well, I've got this negative 4 equals negative 4. Now that is not your answer, but it's going to tell you what your answer is. So when variables eliminate like this and there's no variables left to solve for, that means that we have one of two situations going on. Either we have a no solution or an infinite solution. And since this is a true statement, then that means we're going to have infinite solutions. All right, so if we were to graph these two lines, we would see that they're both the same line. It's one line on top of the other. If I was to take this second equation and solve it for y, I would see that I would end up with that same thing on the top. So there's different ways that you can kind of look at this to verify that it is in fact infinite solutions and that they are the same line. Okay, now let's take a look at problem 5. So on this one we can see that the top equation is written in our general form, but the bottom one is not. And if we were to get them both in that same form, we could use the elimination method to solve it. So that's what I'm going to choose to do on this one. So I can get this bottom equation in general form if I add the 8x over to the left side. Right? When I do that, I end up with 8x plus 2y equals 2. All right, so now let's take these two equations. 4x plus y equals 3, and then 8x plus 2y equals 2. All right, so now I need to see how I can eliminate one of these variables. And I can see that my y's would be easily eliminated if I multiply the top equation by negative 2. Right? When I multiply negative 2 by y, I get negative 2y. I add it to 2y, that will make it zero out. Okay, so I'm going to do that when I distribute this through. I'm going to write it underneath here. So I've got negative 8x minus 2y equals negative 6. All right, let's see what happens from here, right? We were trying to eliminate the y's, and we did in fact eliminate the y's, right? 2y minus 2y eliminates. But look what happened to the x's. We also got rid of the x's. And so we don't have a variable left to solve for. On the left side of the equation, we just have 0. And on the right side of the equation, when I combine those together, I get negative 4. All right, so again, we have that situation where we don't have a variable to solve for. And so either we have infinite solution or no solution. And on this one, when I look at that statement, 0 equals negative 4, that is not true, right? 0 doesn't ever equal negative 4. So when that situation happens, that means that we're going to have no solution. So if you were to graph both of these lines, you would see that they're lines that are parallel to each other. Right? And so there's no solution because there's no place in which those two lines will cross each other. Okay, on these next two problems, I want you to give it a try, see if you can figure out how to solve these, either using the substitution or the elimination method. So pause the video and come back after you've finished these two and see how you did. Okay, let's check and see how you did on this. So on this first one, we can see that when we multiply the top equation by 4 and add the two equations together, we get 0 equals 0. That is a true statement. So that means this is infinite solutions. This is, in fact, the same line. On problem 7, if we try and get y by itself in the first equation, we get this, and then we're going to go ahead and substitute that negative 3 minus 4x in place of y, and then when we solve it, come up with 12 equals 16. Now you could have chosen to do these problems with a different method. You could have done it with the substitution method up here or the elimination method down here. Remember, it doesn't matter which method you use, you're still going to come out with the same answer. So since 12 does not equal 16, right, that is not true, then that means this is no solution. These must be parallel lines. I hope that helped you.